To get started, we'll look at a feature that you can use to limit how many rows are selected. Strictly speaking, this feature is not related to the where clause, but you will almost always have a where clause if you use this feature. Before showing you the feature, we'll look at this simple select statement. We are selecting from the country table where the continent is equal to North America. The results set is sorted in descending order by the surface area. In this example, all of the rows in the table that are in North America are in the results set. There are 37 rows in the results set. Now we see the limit clause used to limit the number of rows that appear in the results set. Note that this clause appears after the order by clause. The result is that the 5 largest countries are in the results set in descending order of their size. As a side note, some SQL implementations use the top keyword instead of the limit clause. MySQL does not include the top keyword, so we will be only working with limit in this course. Now you see another option of the limit clause. In this example, the limit clause is specified as 5, 7. That means that 7 rows are to be displayed, starting at row 5 in the result set. This type of limit is sometimes used in applications that require paging. Paging refers to the ability to display a subset of the data and to be able to navigate forward and backward through the data. You can see examples of paging on websites that display a lot of products. Rather than display a long list in a browser, a subset of products is displayed with the number of options to display, the next 10 or some other number of products. Paging like that is often used with an order by to display products from the lowest to highest, or some other order by option. On the previous slide, you saw the limit clause used with the 5, 7 option to select 7 rows starting at row 5 in the result set. The question is, what does row 5 mean? It turns out that row numbering in the result set starts counting at row 0. You can see the row counter on the left side of this slide showing the row numbers in the result set. It is simply an overlay on this slide. When you start counting items with item 0, this is referred to as zero-based counting. You'll see that zero-based counting is frequently used in programming, although sometimes one-based counting is used. The point is, on the previous slide, we asked for a limit of 7 rows starting at row 5. On this slide, there is no limit clause, so you can see all of the rows in the result set. Note that row 5 is set for Honduras. With that explanation of zero-based counting, you can now review the limit clause again. This slide shows an alternative way of coding the limit clause using the offset keyword. This form of a limit clause is the same as the 5, 7 value shown earlier. You can use either form with or without the offset keyword. When you use the offset keyword, it is more obvious what the numbers refer to. In this example, the offset is set to 5, meaning that the data is displayed starting at row 5. On the previous slide, you saw that row 5 is for Honduras. Starting at that row, the next 7 rows in the result set are displayed. Now we'll move on to comparison operators that you can use in a where clause. Keep in mind the result of a comparison is a Boolean true or false value. The Boolean result is used to determine if the row in the table is to be included in the result set. The most frequently used comparison operator is the equal to operator. Note that this uses a single equal symbol, unlike some programming languages that use 2 adjacent equal symbols for a comparison. The single equal symbol in SQL is not the assignment operator. To select a column that is not equal to the specified comparison value, use the less than symbol immediately followed by the greater than symbol, or the exclamation point adjacent to the equal to symbol. You can use the greater than and less than symbols by themselves. You can also combine the symbols with an equal symbol for a greater than or equal to or less than or equal to comparison operator. In previous slides in this video and in the previous video, you've seen the use of the equal to comparison operator in the where clause. It is easy to understand how the comparison operators work with a numeric column. The comparisons are performed just as you would expect. It is not always so easy to understand how comparison operators work with string data. On this slide, you see an example of a where clause that uses the greater than operator with a character column. In this example, the where clause selects rows from the table if the name column is greater than J. You can see the result set. It starts with Jamaica, the first country in the table that starts with J. One question is, if you selected for name greater than J, why are countries that start with J in the list? That is, why doesn't the result set start with Kazakhstan, the first country that starts with a letter greater than J? The answer is that the country name, like Jamaica, is considered to be greater than J. The comparison is based not only on the first letter, but also on all of the letters in the character string. This type of comparison, a greater than for a string, might be better thought of as select all countries that start with the letter J and all remaining countries after that. Now we'll look at the opposite comparison, where we are trying to select all the rows that do not start with the letter J. The where clause shows the obvious way to write the condition, where name is not equal to J. But look at what's in the result set. You'll see some of the countries that start with I, and then the countries that start with J, then the countries that start with K. This did not work as expected. We thought we were running a select that would not include countries that started with the letter J. But it looks like the selection criteria was completely ignored. What is going on here? Is the database broken? No, nothing is broken. In fact, the where clause on the previous slide worked correctly. It just didn't do what we expected it to do. On this slide, you can see that we are using the substring function to extract just the first letter from the name column. That one character, the first letter, is used for the comparison. On the previous slide, where we just selected based on name not equal to J, the comparison would work for a name of only one letter. So if there was not a country with the name of J, one letter, the not equal would work. A country whose entire name is J would not be selected. To make the comparison work, we need to get one character from the country name. The character that we get is the first character of the name. The substring function can be written as shown here, substr, or it can be written out as an entire word, substring. The function takes three parameters. The first parameter is the column name that contains the character value you want to work with. In this case, the column name is name, meaning the name of the country. The second parameter of the substring function is the starting position within the string. The first character in the string is specified as being in position 1. Note that in this case, 1 base numbering is used, as opposed to the 0 base numbering that is used with the row number in a result set. The third parameter of the substring function is the number of characters that are to be extracted. In this case, one character is to be extracted from the name string, starting at position 1. In other words, the first character of the country name is the value that is returned from the function. Now we have a correct comparison operation. We can now compare the first character of the country name with the letter J. This time, the country names that start with the letter J are not included in the result set.